Okay, so three identical smooth spheres lie at rest on a smooth horizontal table with their centers in a straight line. This first sphere is given a speed of 2 meters per second, and it collides directly with the second sphere. The second sphere then collides directly with the third sphere. The coefficient of restitution for each collision is e, where e is less than 1. Find in terms of e the speed of each sphere after two collisions have taken place. Show that at least one more collision takes place. Okay, so on a really basic standpoint, alright, at the end of two collisions, you can have this going on, right? So example would be this one could be going across at 5. The middle one, which oh sorry, we'll run through this a bit easier. Let's say this one starts off at 6. This one starts off at 0. They collide, yeah. Usually the first one, the one that does the colliding, actually ends up going slower than the one that's being collided with. It then hits the one that's on 0. Okay, so two things can happen when that happens. After that collision takes place, that one's still moving with 2, but this one could be moving with 4, and this one could be going 2 or below. Do you understand? If it even goes 1.8, the other one will catch you up. If it goes in the opposite direction, they'll definitely catch up with each other, right? That's the plan. On a really basic level, that's what we're looking to do. So we'll start off with the first collision. PCM being M1 U1 plus M2 U2 equals M1 V1 plus M2 V2. They're all of mass M, and that's a 2 and that's a 0. And then we have NEL, which is V1 minus V2 equals minus E into U1 minus U2. Okay, so let's find out what's going on. So I'll just quickly set this up really fast. So M times 2 plus M times 0 equals MV1 plus MV2. V1 plus V2 equals 2. V1 minus V2 equals minus E times 2 minus 0. V1 minus V2 equals minus 2E. Everybody alright with that thus far? Add directly downwards. 2V1 equals 2 minus V1, therefore equals 1 minus E. Okay, so that's now 1 minus E. I'm going to find the second one now. What I'll just do is I'll multiply the top one by minus, actually the bottom one by minus, excuse me. So V1 plus V2 equals 2, minus V1 plus V2 equals plus 2E, 2V2 equals 2 plus 2E, V2 equals 1 plus E. So there's my V1 and V2 straight away. So that's 1 plus E. I go to collision number 2 now, and I repeat the procedure. Okay, so just going to shrink that up here, leave it there. Okay, and start off again. Now, once again, PCM and NEL. So I'll start off with PCM for this one. So this collision between the second and third particle. It's M times MU1, so M times 1 plus E plus M times 0 equals, we'll call it Phi3 and Phi4 after the collision. So it equals MV3 plus MV4. All the M's cancel. So what we should have here is that Phi3 plus Phi4 equals 1 plus E. Okay, then we go to NEL. It's instead of Phi1 minus Phi2, it's going to be Phi3 minus Phi4. That will equal minus E times 1 plus E minus 0. Okay, therefore Phi3 minus Phi4 ends up to be minus E squared. I then have to go over here, and I'm going to set up the linear system, or the simultaneous system. Okay, so we're going to have here this time is that add them directly downwards, and what do we get, guys? 2 phi 3 equals, the two of them cancel, don't they? So we're just going to end up with 1 minus e squared. Therefore phi 3 ends up being 1 minus e squared over 2. Now, do we have enough information there with just phi 3? Is there any need to get phi 4? Well, also, if I prove that 1 minus e is bigger than 1 minus e squared over 2, that's enough to prove there's one more collision, isn't there? So the pursuit of phi 4 is unnecessary in the context of this question. Okay, you could get phi 4, it's really easy to get phi 4, but all you have to do is show that there's at least one more collision. Oh wait, find terms v, the speed of each sphere after 2 collisions. Oh sorry, technically speaking, I do actually have to get phi 4. I don't need phi 4 for part 2, but the language says it wants phi 4. Okay, so just be very careful about what you need and what you don't need. So what I'm going to do is I'm going to take this system here, I'm going to multiply the second equation by minus 1. So you're going to have minus phi 3 plus phi 4 minus 1. So 2 phi 4 ends up to be 1 plus 2e plus e squared. Phi 4 ends up, it's a perfect square, but look, there's no need to actually write it as a perfect square, because you actually have phi 4, like there's no point. Okay, so that's the first part done. We're all happy with that. Show that there will be at least one more collision. To show that there will be at least one more collision, I have the current speeds of each one. Current speed of particle 1, current speed of particle 2 has just changed, has it? Or do I have it down here? No, I have it down here. 1 minus e squared over 2. And the current speed of particle 3, 1 plus 2e plus e squared all over 2. Okay, what I'm going to do next is I'm going to show that this speed here is going to be bigger than that one there for there to be another collision. Okay, so what I have to prove, if there's another collision, this means that phi 1, I'll use a different color pen. This means that phi 1 would be bigger than phi 3. This means that 1 minus e will be bigger than a half 1 minus e squared. Okay, how to do this? Multiply across by 2. 2 minus 2e is greater than 1 minus e squared. Bring everything onto one side. E squared minus 2e. The 1 goes over to your side, becomes a plus 1. Yep. Any idea why this is always bigger than 0? Factorize it, and you get e minus 1 greater than 0. It's a perfect square. Perfect squares are always bigger than 0. Therefore, you're guaranteed another collision. A smooth sphere A moving with speed u collides with identical smooth sphere B, which is at rest. The direction of motion A before impact makes an angle 45 degrees with the line of centers at the instant impact. Coefficient of friction is E, no worries there. Show that the motion of A is deflected through an angle A, where tan A is 1 plus E, 3 minus E. Okay, on a really basic level, what we're looking at doing is it's on a current path. Would you agree that it should go straight up this way? The collision is going to take place. It could be sent back this way, or something like this. Somewhere it'll be sent. I'll just assume it's still roughly in the same direction. All you need to find out is what is this angle alpha, the deflection between both of them. Okay, set up like you always do. We're going to have just going to draw a quick picture, before and after. Okay, now it's currently going, are they identical spheres? Yeah. So M, 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 M. Okay, next thing is what speed are we moving at? We're moving at velocity u, aren't we? So that makes it u cos 45 and u sine 45. What's u cos 45 and u sine 45 in third form? U over root 2 both times, okay? So u over root 2, u over root 2. Is the second one moving? It's at rest. It's going 0. Both directions, okay? Then after the collision takes place, what speed is affected? Sorry? The x speed. So we call that phi1. Call the other one phi2. That one's still going up at speed 0. And this one here will be still going up at u root 2. So you can see we have pretty much all our information is pretty much stored in here. So you no need to look at the rest of the question now. Okay, that's what we're looking at. So let's set up PCM, principle of conservation of momentum, along the y-axis only. So it's m1 u1 plus m2 u2 equals m1 v1 plus m2 v2. Okay, so it's m times u over root 2 plus m times 0 equals mv1 and plus mv2. Okay, that will result in phi1 plus phi2 being equal to u over root 2. Everybody right with that? Okay, so that's your first equation set up. You've got a couple of marks on the board already. Now we're going to go for NEL. NEL being phi1 minus phi2 equals minus e into u1 minus u2. So phi1 minus phi2, still don't have a clue what it is. Phi1 minus phi2 minus e into u1, which is u over root 2 minus 0. So what we can get here is phi1 minus phi2 equals minus eu over root 2. Have to solve these two equations. Oh, I forgot. What I might do is they conveniently have a root 2, don't they? So what I could sort of do is I could multiply both sides by root 2. So I could have root 2 v1 plus root 2 v2 equals u. And then I can multiply that one by root 2 both sides. Makes it come out a bit better, doesn't it? So, yes. EU. Yeah, you're right. Sorry, yeah, you're right. Made a mistake there. The root 2 multiplies by that. Just making it EU. Okay. So, what I should get here is 2 root 2 v1 equals u minus EU. And then what I'll get here is phi1 equals u divided by 2 root 2, 1 minus e. I factorised that, then I divided it by 2 root 2. Okay. Now, do I need phi2 for any reason? Remember, the whole point of the question is all centred around which particle? It's all centred around particle A, and its old path versus its new path. Is there any reason I need phi2 according to the language of the question? There's no reason whatsoever. These are the decisions you need to make to get your time back. Don't need it. Okay? So I'm going to now examine particle A in detail. Particle B pretty much doesn't really exist for me anymore. Okay? So what we're saying now is that it was at an angle of 45. Now all of a sudden the new speed is up here somewhere, deflected slightly higher. You'd imagine that angle gets increased. It's not 45 anymore. It's got to be slightly deflected off course, so it's an angle bigger than 45. Okay, so what we're imagining is that phi1 is now, what's phi1? Phi1 is u over root 2 1 minus e. And then what's the other one? U, just still u over root 2, right? Okay. Now what did I do here? Angle of deflection, new path. A plus 45. Okay. So, if I was to draw a quick diagram here, and that's its old path, this is its new path, this here is its old path, and this here is just a reference line. It used to be 45 degrees, that's alpha, yeah? That makes this angle in here what? 45 plus alpha, would you agree with that? I know the opposite and the adjacent, so tan 45 plus alpha will equal u over root 2 divided by u over root 2. Was it 2 root 2? Oh, sorry, 2 root 2. Thank you. 1 minus e. That alright with that? So, therefore, tan 45 plus alpha is equal to, the two of them will cancel, won't they? So it'll be 1 over 1 minus e all over 2. Bring that to the top as 1 over 1 minus e. Just flip the fraction upside down. And that's what it's going to equal, okay? Now, what I'm going to do next is I have to have a quick peek at my answer here. It wants tan alpha on its own, but the e is also allowed in the answer, so I'm pretty close, okay? So, any ideas, guys? What can I do with tan 45 minus alpha? Do you remember the compound angle tricks from trigonometry? I'll run you by one of them. Tan A plus B is tan A minus tan B all over 1 minus tan A minus tan B. Oh wait, plus on the top, minus on the bottom. I'm going to apply that to tan 45 minus alpha. I'm going to get tan 45 plus tan alpha all divided by 1 minus tan 45 tan alpha. That in turn equals 2 over 1 minus e. I'm now going to get 1 plus tan alpha on top and 1 minus tan alpha on the bottom. It's just a matter of separating tan alpha out. That's all I got to do. So I'm going to cross multiply, and it's 1 minus e 1 plus tan alpha equals 2 minus 2 tan alpha. I gotta multiply it out. 1 plus tan alpha minus e minus e tan alpha equals 2 minus 2 tan alpha. Anything that has a tan alpha needs to go on one side. Anything that hasn't got a tan alpha needs to go on the other side. Now, did I end up with an extra tan alpha? Tan alpha 2. Ah, no, I didn't. Thank God for that. Yeah. So here's what's going to happen. I'm going to bring the 3 tan alpha over to 2 tan alpha to combine with the tan alpha. That'll get me 3 tan alpha minus e tan alpha. Then I'm going to bring the e and the 1 over the other side to join the 2. So it's going to be 2 minus 1, which is 1, plus e. Now, just going to quick look at the top again. It wants 1 plus e. That's perfect. So factorize out tan alpha into 3 minus e, 1 plus e, and then tan alpha equals 1 plus e over 3 minus e.